Hey, uh, hey, hi guys. Welcome to this DevDay event. On the online event. Guys, are you able to hear us properly on the Zoom link?
Yes.
Yes.
Can somebody
and
please
clear.
respond?
Yes, we can hear
Yes.
you.
Loud and clear.
By chat is fine. If somebody can speak, that will help us to know if we are able to hear people.
Yeah, we can hear you.
We are
We can hear.
speaking.
Yes, loud and clear.
No, you are able to hear. Okay. If we face problems in audio, you guys can type in the chat and we will read it out. Okay. Yeah. Just a brief about this Dev Day. So we organize this Dev Day monthly. So it's a technical event. We in the past we have done a lot of Dev Days about different technical topics, ranging from HTTP, disk base, and how the disk works, everything. The today's Dev Day topic is on Kubernetes networking. Prashant here is going to talk about that. He can give you a brief about what is the topic and he can start on it. So yeah, welcome again. I'll hand it over to Prashant.
Thank you. Am I audible? So I can't hear you guys for whatever reason, I don't know. So probably you will have to put in it in the chat for any questions or anything that you want to say to me. Okay. So should we start? Yeah. So let's start. So one of the topic, this topic essentially, it came out because I have seen that people are using Kubernetes in the projects, but then there are certain gaps that we don't really understand how things essentially works. And even you don't need to actually go too deep to understand. We are not going to talk about too much of like networking layers or anything like that. But fundamental components that we use on day-to-day life, how do they actually allow us to communicate with Kubernetes? And this, once you understand this, then you really understand the setup of your infrastructure that is done and how Kubernetes actually is working with your cloud provider and allows you to expose your services. And this will also help you in terms of debugging any issues or understanding or even designing that which services should be internal, which services should be outside, which services are part of which domain or which applications and all those things. Okay, so that's where this the concept of this thing comes out. We had some discussion around this internally, and then we realized that there are gaps. So instead of just doing it internal session, we can say that we can do it as a Dev Day. Okay, so this is the general idea, agenda that I'm going to actually go on with. So the pod communication. So this is very basic in terms of that you have multiple pods. How do I make sure that they communicate with each other? So we kind of know that we can communicate with each other, but how does that really work? And if I need to do that, how do I do it? Then there are the main concept in this is the service, the Kubernetes services that are supported. And there are at least 3 of them that I'm going to cover. Okay, and then we can see that why do they need and what they are actually solving. Okay, you don't need all of them. You need to know which one you are going to use for a given particular problem or given situation. Then the next concept is the ingress and ingress controller. Okay, so we are going to talk about what is ingress resource, what is the ingress controller, and what is a controller in general, and why do we need ingress if we already have something like a service. Okay, so that's the overall agenda of this talk. One thing about this is you will at the end of it, once we cover everything, you basically see the end-to-end picture. So we will be able to access the Kubernetes applications over the internet. Okay, and we are not going to create a domain as such, but then you can just add a domain and it runs the same way. Okay, as long as you have access, then you can attach it to a domain, and then it essentially runs the same way. Okay, so that's the general idea of the talk. Okay, so we need some examples. Okay, so I've just gone up and we just have two services, simple things. Okay, even if we can expose these two, the same thing is there for the rest of the application that we have. Okay, so we are going to go with two services. We have just a customer service and a product service. Both of them have one endpoint called customers and the customer ID. So /1 is essentially the ID. And products is again the same thing. You are asking for the product details. So you essentially say product/1. Both of them are GET requests. So simple example, but you will see that we need to still do a lot of, we will go through all this for a lot of concepts that are there in Kubernetes. Okay. So what we can do is let's start with a pod. Before that, I will just show you my screen is visible on the call as well, right? Okay.
Yes.
Yeah. So I have a repo online. Okay. That if you want after this talk as well, you can go and actually refer to this. There are lots of things that I have done as part of it. So prerequisite is essentially all the setup I already did. Okay, like setting up the kubectl, setting up the cluster in Kubernetes, Kubernetes cluster in AWS. I am using kops for that. So all those commands and everything is in place. If you want, you can follow it later. Okay, so this is where the session essentially starts. Okay, so I'm going to refer to most of these things. We will go through all of this. And essentially deploy all this on the Kubernetes cluster. So I will just show you the cluster right now. So if you see, okay, one thing I need to say here is, so generally we use kubectl, correct? I can say GoIt nodes. So I have created alias for that. It is easier for me to do that. So KTL is essentially kubectl. Any commands that you see here with KTL, it is kubectl. So is the font visible? It's visible. So you can see that we have a cluster that has like 3 master nodes. So it's the HA setup. And we have 2 worker nodes that are running as part of it. Okay. We right now I'm using the default namespace. So I can check whether there are any pods on this. So right now there's nothing there. Okay, no pods are there. So we haven't created anything yet. Okay. So now what we are going to do is, as we said that in the okay, this is better. Okay, so what we said is we'll start with deploying a pod. So simplest thing we can do is we can just see that can we deploy the customer service or one of the service as a pod. Okay, so this is a simple pod definition that we are essentially using here. Okay. So customer service is so we have created a container already. So you can see that it is referring to an image called as customer service. And that customer service is just a plain, I think, Spring Boot application, which is running on port 8080. I can actually run the Docker here if you guys want. How do I get rid of this bar. Do we know that? Sorry? Drag what? This one. Okay, where is it? Yeah, good. Okay. So what I can essentially do is I can just run the pod locally. So this is nothing to do with Kubernetes. I'm just running it on my local. So what I'm doing here is I'm actually saying that run this image. Okay, this is the image tag. And we are saying run this image. And the only thing we are doing here is kind of a port mapping that allows me to access the application running. We are going to revisit this, the same command again. Okay, so what we are saying is your port 8080 that is within the container is mapped on this port on my machine. Okay, I can actually also do one more thing. Or okay, let's go with this. Okay, so this is actually running a simple application, and you can see that it is saying that I can access it on this particular thing. Obviously, I haven't mapped it to 8080. I have mapped it to 18080, so I have to change that. But I can just go and do that. So if I just open that up, okay. So customers one. Okay, so I am able to run this container locally, and it actually gives. Okay, so it actually gives me a response back. So I am able to see the container details of the customer one. Okay, now let's do the same thing or similar thing with a pod. Okay, in this case, we are saying that I want to create a pod. Okay, in Kubernetes, the name of the pod is customers. I have added a label called app with customers as the value, and then I am defining container. So this is where I am defining a container. I'm saying that the name of the container is customers. This is the image, and the port in which the application is running, that's the container port, is 8080. Okay, so 8080 is where the application is running. So let's do the same thing. So instead of running it on our local, let's actually run this against the on the Kubernetes cluster. So you can say that right now there are no pods in the namespace. So I can actually say, give me a customers. Okay. So all I did is apply that YAML, same definition. Okay. And then let's see whether a pod is getting created for us. So it is saying that it's already running. So it actually goes through creation of the container and all that. We can also see the details of that pod. So if I say customers, whether it picked up the same details that we passed in, it gives us a tons of details, to be honest, but whatever we passed in, we can actually check that. So if you go up, annotations, we don't need to worry about that. So we are saying that it's a pod. Okay. So now I'm looking at the YAML inside the Kubernetes cluster. So it is a pod and its name is customers. So that's what, when you do kubectl get pods, you will get this. And in the end, you are saying that these are the containers and this is the image that with which it is running. This is the container port that we have passed in. So it essentially picked up everything that we have deployed. Okay, great. But how do I, sorry. It is deployed to? Is it on what? It's not on local now. It's on the cluster. So that's why. So if you say kubectl, I'm actually talking with the cluster. Okay. You can also see that it is running on which node. Let's see that. Okay. So if I say get pod again, okay, and let's look at the details, extra details, we should be able to see which node it is running on. Is it status? Okay, so this is the node it is running on. Okay, so this is not my local machine. You can see that. I can show you that. Okay, my local machine is 192 something something. This is a machine that is running in EC2. It's a EC2 instance. We can actually go and check that EC2 instance. Okay, so this is actually running on this machine. Okay. Okay, so that's where this pod is running, or this application is running. Great, application is running, but how do I do the same thing that I did locally? I was able to access the customer's endpoint, but how do I do it? Now I have deployed the pod. Okay, so so what do we actually need when we want to actually communicate with an application? What do you think? What do we need? Which information we need to actually communicate with any network? Yeah, so basically you need an IP and a port. Okay, so if we have an IP of some kind, and if we know which port we need to reach to, then we should be able to communicate with that application. Okay, so let's try to figure out what actually is the IP address of this pod. Okay, so we already have this definition opened up. Host IP, we saw that it is the IP address of the node. Okay, but we also see something called as pod IP. Okay, so it is saying that there is an IP address of this pod, which is 137 in this case, ending with 137. So what do I do? How do I access this? Can I actually do anything with this pod? If I ping this IP address, I don't think I will be able to do anything with this. Okay, so this IP address is not within the same network that my laptop is. Okay, it is in the cloud on that AWS, and that too, it is not even part of the AWS, it's part of the cluster itself. Okay, so this pod or this IP address is only resolvable within the cluster. Okay, that means I should be able to communicate from another pod of the cluster to this pod. Okay, so let's try to actually install some other pod. So right now we have just one pod. Correct. So if I say, so if I install one more pod, in this case, I am installing Nginx pod. Okay, so it is saying creating we don't really need that. Okay, so now both of them are up and running. So now what we are going to do is we are trying to actually access the customer endpoint from the Nginx. Okay, so because both of them are part of the same cluster, I should be able to use the IP address and reach the pod essentially. Okay, so let's try to do that. So how do I access or send a request from Nginx to the other pod, the customer's pod? So Kubernetes actually gives you a way to execute random commands on the pods themselves. So we can actually do that. So I can actually say Nginx, and I can say curl whatever was the IP address of this guy. So I'm using the IP address of that pod. I already know that the service runs on port 8080 because that's the container port. That's where the application is running. Okay, or listening. Okay, and then we know the URL as well. So that is the URL. So I should be able to actually get a response from it. And you can see that I am actually getting a response. Let's actually make it a bit beautiful. Okay, so I'm able to get a response from this particular pod. So I'm able to send a request from Nginx pod to my pod on the pod IP. Okay, and the port that pod is the application is running inside that container. Okay. Now, also, so I'm not going to show it as an example, but just a footnote is the IP is at the pod level. Okay. And if you see the pod definition, pod can contain multiple containers. Okay. That means if I have multiple containers in a single pod, all of them will have the same address within the cluster. So same IP is there. That also means that they are within the same, it's like localhost, they can communicate with each other on a localhost thing. And anyone else is need to communicate, they are at least need to make sure that the pods container ports are different for those applications. Then only you will be able to reach, because you have a single IP at the pod level, not at the container level. Okay, so if you have 3 containers in a pod, you basically have one IP for all 3. Okay, so that is good. So we are able to actually access this. But what about if I have multiple pods? I cannot just go randomly and say that, okay, this is the IP and now send it. I don't want to just run one pod of an application, right? We never do that. There are tons of reasons why we don't do that, because we want to be able to essentially say that. So in this case, the reason I have said that auto recovery is not there, because if I delete the pod, that's it, it's gone, not going to come back. Okay. For that, we are going to use a deployment that I will show in a bit. Then the next reasons are you need high availability. So if my pod dies, at least there should be someone else, some other pod of the same application which is still up and running and serves the traffic. Okay, so you basically need multiple pods for a application. Auto scaling is essentially sharing the load. I don't want, like, if I have like huge scale, I am going to run multiple pods. One pod is not going to serve all the traffic, which is not possible. And then if I am rolling new versions of the application, as part of that, if I don't have multiple applications, again, there's a possibility that you end up with a downtime. So all these are, there are multiple reasons essentially, but you are not going to just deploy one application, deploy an application with a single pod and that's it. You will end up with a situation in which you have multiple IPs or multiple pods. Now the issue with this is, so Nginx, what we did, we sent a curl request from Nginx to a single pod IP. Okay, but if I have multiple of them, now how do I do that? So if I have service 1 and service 2 has a multiple IP, how do my service 1 actually communicates with it? If it just sends it to one IP, then rest of the pods are not really doing anything. If I say that no, you need to use all 3 of them, then it's a headache for the service to do round robin or some kind of thing. And then it also needs, if you put in auto scaling in it, then how does it know that which pods I need to communicate to? If my pod goes away and comes back up with a new one, if I replace the pod, I might end up with a different IP. So that is also not going to work. So all kinds of issues are there. Pods are, the IPs are not going to be stable, and I have multiple of them. So what is the solution? Okay, so what actually, before we move on, I just wanted to highlight, and this is kind of an important thing, because this also will allow you to understand where we are when we are looking at the images in this presentation. So anything that is marked with blue, essentially all these components are Kubernetes components. Okay, anything that is marked with a green are the AWS components. Okay, and anything that is marked with orange is essentially a shared component, which is a mix of Kubernetes as well as the AWS. So for in this case, the example will be the nodes. So node is actually a EC2 instance, but it is also a node which is part of your Kubernetes cluster. So if I do kubectl get nodes, okay, so Kubernetes does know about all these nodes, but at the same time, these same nodes are also visible as EC2 instances here. So it is basically a kind of a shared resource in that case. Okay, so just keep that mentally when you are looking at the images here. So that also means that anything and everything that we are talking about here is still within the cluster. Okay. So we end up with multiple pods. What we actually need is a single stable IP. Okay. We don't want that IP to change, okay, frequently, and we don't want to manage IPs. So if pod goes up, if I scale out, if I scale in, if there are 3 pods now, there are 5 pods later, and then I scale in, then there are 2 pods. I don't want to actually keep on knowing how many pods IPs are there and all that. So all I need is a single IP that I can connect to. Okay, I don't need multiple of them, and that too I want kind of a stable IP than a IP that is given by the pod itself. Okay. So now in this case, again, every component here is still within the cluster. We are still within the cluster. Okay. So that's exactly what your cluster IP service type actually does. So Kubernetes services, we talked about Kubernetes services. I will show you how the service looks like and what it does. So one of the type of the service is cluster IP. This is the default type. Okay. And we will see why it is called as cluster IP. But you can get a guess essentially right now is it is giving you a IP, a stable IP to communicate to, in which you don't need to know about the underlying IPs of the pods. You don't need to actually worry about how many pods are running. Is this 3 pods, 5 pods? Is it scaling up, scaling down? You don't need to know that. Okay. You will get a single IP to which you need to communicate to. And that's it. That's what you're doing. Okay, so that's the cluster IP type. Let's actually check and see how does it look like. So if I need to do that, how will it actually look like? So now we are creating a resource of type service. So earlier we created a resource of type pod. Okay, now we are creating a resource of service type. Again, the name is kind of same. We gave the customers as a name. Then here we are saying that, so there is something called as a selector. Okay, what it is doing is it is saying that I am an service. Okay, which will try to find out the pods that has this label. Okay, that's what this selector is doing. So that means if we want our pods to be served by this service, we need to make sure that our pods actually have this particular label. Okay, so even before we go ahead, let's actually create this scenario. Let's actually create. Okay, what's the question? Where do I look at the question? Okay, how do I go to that control again? Escape. Oh, good. Can one node contains multiple different types of pods? So the question is, can a single node contains multiple types of pods? The answer to that is yes. So in case of Kubernetes, what you essentially do is you say that I need to run these pods, and Kubernetes is the one that tries to map the pods to the nodes. Okay, so when we are defining a pod, we never say that we want to run it on a particular node. You are not going to do that. You can do some kind of selection, okay, if you want to do that, but in general, by default, you never need to choose a node. Okay, Kubernetes will assign a node that it thinks that is the correct fit for that pod. That also means that one node can host tons of pods. Okay, and if your pod or a deployment, if your application has multiple pods, they might end up with the same node. They might end up on a different node. If you want to make sure that they ends up on different node, you have to make sure that you configure your services correctly. Okay, so I can close this. Okay, so before moving to service, let's actually try to recreate this this scenario in which we have multiple pods of the customer application. Okay, so for that we have something called as a deployment. Okay, let me actually close everything on. Okay, all others. Okay, so we have something called as a deployment. So it is of kind deployment. What it is doing is, so if you see any resource in Kubernetes, it has these sections. It has a API version, it has a kind, it has a metadata and a spec. Okay, these are the main 4 things that will always be there. Metadata is mainly extra information about your resource that you are defining. Spec is where the main thing is, main configuration is. Okay, so in this case, what we are saying is, we are saying that we want 3 replicas of something. Okay, and it is saying that it is also giving a selector which says that the pods essentially which are under the which has this label as part of it are the ones that are managed by this deployment. Okay, now it has something called as a template. So this is more like a pod template. So instead of defining 3, so we are saying that we need 3 replicas of the pod that should look like this. Okay, and then it starts with the metadata and a spec. Okay, so it's like a mini sub resource definition. Okay, so it has a metadata and a spec, and this is kind of identical to what you saw in the pod. Okay, so almost everything that you have here is actually here. Okay, all you are saying is I need a container called customers. This is the image of that container, and this is where the application runs in that container. And then I have added this label. This is the same label that is actually used by the match label. So that's what the labels are being used to actually connect and manage the pods. Okay, so let's try to actually update this. So if I say get pods, right now I have 2 pods. Okay, I can get rid of that pod. I can say delete pod customers. Okay. Why it's taking so long? Okay. So now if I say get pods, there is only 1 pod running, which is Nginx. Now let's try to actually apply the definition of the deployment rather than a pod. Okay. So it is saying that it is created. All of them are essentially running. So now I have 3 copies of the customer pod, not 1. And because why we have 3 copies? Because we are asked for 3 copies. We are saying that give us 3 replicas. So obviously all 3 of these do have different IPs. You can see that my pods essentially have different IPs. Okay, so this is one, probably is difficult to read, but this is one record, another record, and the last record. These are the 3 pods, and this is the Nginx pod. All of them have different IPs. So essentially we are having this situation. Okay, and we don't want this situation. We want a stable IP. Okay, so 3 pods of the customer. Yeah, I can also show you that deployment is created. So it is saying that I need to create 3 replicas. That's what it is saying. All of them are available. Okay. Now what we can do is we can now create this service that we are talking about. So let's look at the service definition. Okay. So all we are saying here is I want a service type. It is called as customers. It basically caters to all the pods that has app label of type customers. Okay, and then I'm going to talk about the port, but the main thing here is we are saying that it is of type clusterIP. Okay, so now if I create this service, let me check underscore service. Okay, so now let's see whether this service is created for us. Okay, so you can see that service is created. Ignore this thing right now. So service is created for us, okay, called customer. Let's see what it actually gives me. So I can say describe that service, basically gives me more detail of what is happening there. Okay, so as part of it, what it is saying is it is of type cluster IP, so which is expected because we are saying that we want a service of type cluster IP, which we are saying here. Okay. And it is saying it is giving us an IP called this. This is a new IP that is given. Now, if you see the pods, okay, this is not the IP of any of this pod. Okay, it's like a completely different IP. Okay, so my service definition essentially is giving me a IP address. Okay, so that is probably the stable IP that I'm going to get. Okay, so instead of 3 or 4 or 10 IPs, I am now going to deal with one IP. So again, it should be easier to actually do this. Should we try to actually use this IP and try to access the customer? Okay, let's do the same thing that we did. So what we did was we tried to access it from Nginx. Okay, so let's try to do that. But in this time, instead of a pod IP, we are going to use the service IP. Okay, so we are able to hit that endpoint with the service IP as well. Okay, and on the same port that the pod is actually running on. Okay, so great. So at least within, so right now you see the diagram again. Okay, let me go. Okay, even if after the introduction of the service, we are still within the cluster. Okay, we are not able to access this service from outside. We are still within the cluster. Everything is still blue. Okay, so great. So now the question is, how does the service actually knows what are the pod IPs? How does it do that? So if you actually see here, when we did a describe customers, where is that question? Okay, so there is a question in which is saying that does service IP change? It is possible that it might change if you recreated the service. Okay, it is less. In a way, you can say that it is much more stabler than a pod IP. Okay, so anyway, it is an improvement. Okay, but we are going to talk about something extra that makes it even stabler. Okay, so service IP can change. If I delete a service and recreate it, it is going to change. But that also means that I end up with a downtime. Essentially, my service is now down. And your business is affected because of that. Okay, so it is less likely that you will recreate a service, but yes, it can change. One more question. Chat. Selector mentioned in the service matches with the labels mentioned in the pod or labels mentioned in the deployment. Okay, it is matching with the pod labels. In this case, all of them are same. Okay, you can see that the the label on the app customers is what is the same label that is there on the deployment. So that might be the confusion, but it is not looking at this thing. It is actually looking at this. Okay, so it is the pod label, not the deployment label. Okay, I can have different deployment label, but the pod label is what service is trying to figure out. So selector is for the pod labels. Since we use cluster IP when we queried, how did we know from which pod the data was pulled? We don't know. Okay, so it might actually go to any of the 3 pods. So the question that was asked on the chat was which pod the service the request actually went to. Okay, so we don't know. Service generally just do, so it is actually doing a load balancing for us. It does a round robin between the pods and sends the traffic. So now it is actually distributing the traffic for us. So we are getting an added benefit. At the same time, we are getting a single endpoint to actually communicate to, which is much better. So it's already an improvement. Okay. So now we are talking about how does it actually is able to figure out what are the pod IPs. So if you see there's something called as an endpoint. Okay. And the endpoint is again bunch of IPs. Okay. 3 to be exact in this case. So where are these IP coming from? Any guesses? These are the pod IPs. So if you see, if you match this, these are exactly the pod IPs. So this is 140 is there. Then 113, 38 will be there. Okay. And 139 will be there as well. And basically it is also saying that the container IP, container port is 8080. So that's how it is actually able to figure out. And this list is continuously updated as and when the pods are changed. So if I delete a pod, the IP addresses will be changed. It also creates something called an input. So endpoint is just shown there. Okay, but it actually creates an endpoint for us. You can see that the endpoint record is created. We didn't create this. Okay, we just created the service, but service created an endpoint that is named exactly as the service name. Okay, so it is also named as customers. Okay, and this endpoint is actually maintaining the IP addresses of the pod. Okay, so Kubernetes ensures that any changes in the pod, because Kubernetes itself is managing the pods or figuring out if the pod dies and all those things. So it kind of knows that pod is changed or something is changed. So it tries to keep up to date the endpoint list. Okay, and those endpoint list is what the service is dependent on. So service essentially sees the endpoint list, and that's how it is routing the traffic to. Yeah, what's the question? Oh, it's within here. Okay. Can we specify algorithm for service to use different algorithms instead of round robin? We might, I don't know, we can check. So one of the good way of figuring out what all things you can do in general is to actually use a kubectl explain command. In this case, you can actually do a lot of things, and you can see that what all things I can configure. There are tons of things there you can configure. You might or might not be able to choose an IP. So in this case, I think one of the reason you might want to choose is like a stateful application, or there is some state like session or something, and then you need a stickiness, and then you configure. Generally, you don't do that. You try to avoid it. You want to, if you do that, your load is not actually uniform. Okay, so if I add 2 more containers, if I have 2 containers, if I add same number of containers, essentially double the containers, there is no guarantee in that case that I actually reduced the 50% of traffic or do that. So it's not linear in that sense. If you not do a round robin, all pods should be like same. Okay, it doesn't matter how many of them. If that is not the case, if you need to know where do I send the traffic, then it is kind of a stateful service, and then you need to deal it in a different way. There is something called a stateful set that you can use. We are not going to talk about that in this. I want to keep it as simple as possible here. Okay, but what I'm trying to say here is it's kind of a complete documentation. You can see that clusterIP, external IPs, and tons of things, and it also gives you an explanation of what it is. And it will also give you links to the documentation. Sometimes it might have, so like this or like this. Okay, so it gives you a documentation links as well. And in a way, because you are asking it within the context of your setup, it might be aligned to the version of the Kubernetes that you are using. So that is a good way to figure out what all I can do as part of the definitions of these resources. Okay. Okay, but I don't want to deal with IP addresses and ports. What are we doing? Okay, so no IP address and ports. We don't want that. Okay, so how do we actually get rid of this? Commonly, we don't actually use IP addresses at all. Even if that is how the internet is working, we don't really say that Google, instead of Google, we don't say some number and then that's where you need to go. Okay, so you essentially use a domain name of some kind, and we never use a port as well, because we have assigned a well-known ports to the protocols. So that way we don't need to deal with that. Okay. So let's go with this, at least the well-known port. So we didn't do one thing here. We just said that there is a port that is mentioned here. Okay. And that in a way, we just said that it's same as 8080 basically. But that's not you need to do. You can actually change it. You can also see it here. Okay. It is saying the port is 8080. That's what it is saying. And target port is, so there is something called a target port as well. Target port, it is saying that it is also 8080, but we didn't state that. Okay. So it figured it out that target port is 8080. So in this case, what I'm going to do now is instead of going with 8080 as a port, I will go with a standard 80 port, which is the HTTP port. So that way I can at least get rid of one component, which is the port. I don't need to worry about the port. Okay. So in this case, what I'm saying is my service will accept the traffic on port 80 and it will send it to send that traffic to port 8080 on the pods. So pod will still accept traffic on port 8080, but for service point of view, I don't need to worry about 8080 and all that thing. So if I apply this thing now, okay, so I'm applying that same YAML, this one. So now if you say get services, okay, you should be able to now see that it is actually trying to listen on port 80, not 8080. Okay, so now if I do the same thing, let's try to access the customer's application from Nginx pod and get rid of the 8080 thing because we don't need that. So at least we got an improvement in a way. Okay, so port is now gone. What about the IP address? Okay, I don't want to deal with the IP addresses as well. That's where the Kubernetes, so Kubernetes actually has a DNS setup. I can show you that as well. I'm not going to go into detail of how we can go it if we have at the end of the session, if people want to know about that, we can do that. But I don't think we will get time to cover that probably today. Okay, there are tons of things that we want to cover. Okay, so if you see this one, if I say DNS, there is an internal DNS within the Kubernetes cluster. So these are the DNS gives me ability to use DNS. So that means instead of using IP addresses, I should be able to use some well-known names. Okay, the way Kubernetes services works is every service that I create, okay, I will get a corresponding the service name is used as the DNS for that service. Okay, so that means I should be able to use the service name, which in this case is the customers. Okay, so instead of IP address, I should be able to say that send my traffic to customers, okay, /customer/1. Okay, so that's what I should be able to do. So this is a service now. So instead of an IP address, if I actually use the service name, which is customers in this case, then I should be able to access the same 3 pods, okay, or the customer application through within the cluster essentially. So now it is much more even stabler than the IP address that you get from the Kubernetes from the service itself. Okay, so that is definitely a big improvement for us. So instead of IP address, we are saying we'll use domain name. Instead of port, we'll say that let's use the standard ports, so no need to mention the ports. Okay.
Service name is only resolved within the namespace, right? Not
Yes. Yes.
one difference between IP and but IP is resolved within the whole cluster.
Service name is resolvable across the cluster, not within the namespace. So that's the bonus section that I was going to talk about. I'm not going to talk about that. So what he's saying is that service names are only accessible within the namespace. Okay. That is not the case. You can because the IPs are at the Kubernetes cluster level, they are not specific to a namespace. The domain names are also not specific to namespace, but it's a short version that we use, and we basically just avoid the namespace and everything. And that's why you don't need to mention that. But you can access from one pod that is running in one namespace, can access another pod that is running in entirely different namespace, as long as it is within the same cluster. Okay. Okay, so till now, yeah. You can have same service name between two different namespaces. By the definition of namespaces, it allows you to do that. Okay. I didn't want to go there. We can cover that in the bonus thing. What I want to try to do is I want to complete it end to end. Okay, if I just do some of this, then you will not actually get everything. Okay, so we can talk about the bonus section, which is the DNS, how DNS actually works, but let's talk about that later. Okay, there are tons of things that goes, but it is possible. And the namespace allows you to use duplicate names. That's the whole point of namespace. So I can have the same service name in two different namespaces. I can have same pod in two different namespaces, same name pod in two different namespaces. Okay, so all that is possible. That's why the namespaces are there. Okay, so till now we are in the blue zone. Everything within the cluster. Great. You can communicate between the pods, but I need to communicate from outside. Okay, so how do we do that? Okay, how did we do it in case of the container? We already did that, right? We run a container locally, and we were able to access it as localhost, or we didn't use the IP address, but we could use the IP address of my laptop, not the IP address of the container or anything else. Okay, so I should be able to do that. So here what we are doing is we are doing a port mapping kind of a thing. I'm saying that that the port 8080 should be mapped to port 18080 on my local machine when I actually execute this Docker run. So let's actually do that again. So if I do Docker run this service, okay, so it runs. And now if I go to localhost 8080, we already tried this. Okay, let's go actually and use not localhost, but my IP address. That will also work. Okay, so my IP address is 192.168.1.73. Okay, so this should also work because of my setting, it basically gave me that it is a HTTP. It's not a HTTPS request, which is correct, which is not secure essentially. But I am able to access the pod contents, okay, on the IP address of my local machine. Okay, so if I do that, that means now from a client point of view, I don't need to know that you are running it as a container, or it is as good as if you are running it on this machine. Okay, that means if I know the IP, if somebody else is there who knows IP address of my machine, will be able to access it as if it is just an application running on my machine. They don't need to know that it's actually not running on my machine, running inside a container. Okay, they don't need to know that. If we can achieve the same thing, then you can actually access it on the node. Okay, now we are coming out from the pod or container world onto the node side of things. Okay, so if I am able to do that, then I should be able to access the thing. So how do I do the mapping? Okay, so that's exactly what the node port type service is actually giving you. As the name suggests, it gives you a node port. It's a mapping on your node. So it gives you a port on your node, which is mapped to the container or the pod port. Okay, so same thing that we did for the Docker container, we can do it by using the node port service. Okay, so now see the color coding. So everything here is Kubernetes. Okay, this is a shared resource because it's a node. Okay, it is within the EC2 instance because it is within the AWS, as well as it is part of the Kubernetes cluster because Kubernetes understands the need to run pods on that node. So that's where the pods are running. And the client is something that is within the AWS. Okay, so we are now within AWS, not still entirely public, but outside of the Kubernetes cluster. Okay, so if we do this, okay, let's try to do this. I'll get rid of this node port. Where is it? Okay, is this visible? Zoom, na? Yeah, that's what I'm trying to do. It's not doing it. Yeah, but then something weird is going on.
Command plus will also.
Command plus is not working for whatever reason. Let me know once it is visible. Huh? This is better. Okay. So now what we are saying here is, so this part is all same. Okay, port 80, great. Services are accepting traffic on port 80. Target port is same. That's where we need to send the traffic to. This type is changed. Now instead of cluster IP, we are saying I want a node port service of type node port. And at the same time, we have added something called as a node port, which is basically, so we chose a port which is 3001. Okay, or is it 3000? There is a question. What is the question? Is node port service part of AWS or Kubernetes? The service definition is part of the Kubernetes. Okay, but the port on which the port is essentially opened up on the EC2 instance. So instance is part of AWS. That's why I showed it as a shared resource. But the service definition, the service we are creating is within the Kubernetes cluster. Okay, does that clarify? Okay. I think somebody already answered that, to be honest. Okay, so let's see the services. We are still have cluster IP service. Okay, we still have cluster IP. Let's change that. So if I say apply, and instead of this, I say node port service. Okay, so something has happened. Okay, so now it is saying it is of type node port. And if you see here, it was just saying that I'm accepting traffic on port 80. That's all it is saying. But now there's something different here. It is saying that it is port 80, which is mapped to port 3001, and all these things. We can also see some more details, but that's the only thing that is actually changed. So it did a mapping of the port 80 of the service. Now we are not mapping the port IP. We are essentially saying that the service port 80 is mapped to 3001. Okay, pod port is not mapped. Container port is not mapped. It's just the mapping between the service port. Okay, on the EC2 instance. What that means is now if I use the EC2 instance IP address and send my request to 3001 for the customer, I should be able to reach to the pod, whichever pod that service is actually serving. Okay, so any customer pod my request will end up with, but I should be able to do that. I should be able to use the IP address of the EC2 instance, send the traffic on this port, and I should be able to reach the pod. Okay, so let's try that. For that, I need to be inside the AWS VPC. Okay, I cannot do so that IP address. So even if you get the IP address, okay, let's also see one more thing. Okay, that where this guy is running. So let's say that which node is that. Okay, let's not do that. Let's get the nodes. That's it. Okay. So these are the nodes. I can actually get the IP addresses, but this is essentially the IP address of the node. Okay, so if I choose one node, this is master node, so I'm not going to choose that. This is the node of type. So this is the worker node. I can choose this IP address. If I basically try to ping this IP address or do anything with it, it's obviously a private IP. And I purposefully made the setup in a way that is like real work kind of thing. You don't want, so I could have created a cluster that everything is a public IP, but that's not what you are doing on your projects. You don't want to do that. You want your clusters to be private. You don't want to open that up. So this is not going to work because this is a private IP. It's not going to work. It's only going to work within the EC2 within the EC2 within the AWS VPC. So that's why this is marked as green. It's not public. Okay, so that means I have to actually log in to. So I have created a bastion. I can log into the bastion. Yeah, so this is the bastion. Now I do same thing. If I do ping and the same IP, it should tell me that I am able to ping to that thing. Does it tell me anything? Or is it doesn't work on EC2 instances? Okay, let's try to actually directly do what we are trying to do. Okay, so what we said that we want to do curl. Okay, on HTTP. So that's where the port is, but we are going to use the port. So in this case, I need that same IP address of the node. So this is a node IP address. Okay, and I need the port which we used as a node port. Okay, /customers/1. So I should be able to get something out of it. So you can see that I am able to reach to that pod. Okay, one of the pod, but I am able to send my traffic to. And this is the first time we are doing it out from outside the cluster, not within the cluster. Okay, so at least we got something there. Let's make it a bit beautiful. Even I don't want the progress bar as well, so it is easier to see. So we are able to essentially able to access the customer pod from within the EC2 instances at least. Okay, so now which is good, let's go to.
So it opens up the port on every node on the cluster.
Yes. Okay. So again, there is a setting to not do that. You can choose not to open it up on all the thing, but then if you are using this setup, I will not do that. I will tell you in the next section that in that case you can actually do it. Okay, but you can essentially say that I don't want to open up it everywhere. Just open it up on the nodes where exactly that pod is running. Okay, and that is possible. So now again, coming back, we chose any random node, right? We didn't say that, okay, this node or that node. There were 2 nodes, 2 worker nodes and 3 master nodes. We chose any of them and say that, okay, just try to send a request to it. And it just worked. Okay, we try it, we can try it for the other one and it will still work. Let's try that. Okay, so if I have, what is the other IP addresses? Okay. Okay, so we chose this one. I can choose this one. And it will still work because that's the default behavior. Okay, and that's kind of a downside as well. There are 2 downsides. but it also guarantees that it's going to work. It's not going to fail. It doesn't say that it's every node will know where to send the traffic to. Okay, so that's what it is doing. It is able to do it actually across both the nodes. That means now port mapping is not done only on one node. It is done on all the nodes, all the worker nodes on the cluster. Okay, so that's what it is showing here. So because these are shared components, that's why they are colored like that. This is where we are trying to do. This is the bastion node. Okay, nothing to do with Kubernetes cluster. No Kubernetes component is running, so it's not Kubernetes doesn't know this node. Okay, so this is purely EC2 instance sitting outside of sitting in the same VPC but outside of the cluster. So nothing to do with cluster. So that's why it is green. All these components are all blue. Okay, so they are part of the cluster. Okay, so this is good that we at least are able to now access the service from the AWS. Okay, so what we got, okay, what is the relationship or kind of a similarity between the node port and the cluster IP type of service? So in case of cluster IP, all we got was the cluster IP. Okay, cluster IP service. In case of node port, we got a cluster IP as well as a node port. So if you see, we actually also have a cluster IP. Let me get rid of this. I'm back to my own machine now. If I say get services, you can see that I still, even if it is part of, even if it is type of node port, I still have the same, I still have the cluster IP assigned to it. So that means it's still a cluster IP thing, but something extra. So in a way, you can say that every node port is also a cluster IP service. Okay, but it also has something extra, which is the node port mapped to all the nodes of the cluster. So this is extra what we got. So in a way, it will still serve all the internal traffic with the standard IP, and it will also have a DNS record corresponding.
Your master public?
No.
How your laptop is communicating to master?
COPS setup. So I have a API gateway exposed through the load balancer, but the nodes themselves are not public. They are still private IPs. Okay, but the load balancer that's sitting in front is actually public. Okay, in production setup, you don't do that. You can avoid that doing that. Okay. Okay, but we can't really rely on node IPs, right? The same goes. So I think we did the kind of a similar argument in case of pod IPs. We said, I don't want to deal with pod IPs. Okay, now we are saying that now deal with node IPs. It's like weird, same thing. So you can't use node IPs because which node? Say if I have like 10 nodes in my cluster or 100 nodes in my cluster, I'm not going to deal with 100 IPs. And if I throw in like things like auto scaling and all that thing, then it's like continuously changing. Who is going to track that? And how do I send traffic uniformly and tons of things? Okay, you don't want to treat your nodes as a set of things like so ephemeral is essentially they come and go. It's all dynamic. You don't want to say that this is the machine where this service is running and this is where I sent and never touch this machine again. That's not the right approach for a cloud setup. Okay, so and scale in, scale out. So all those are the reasons you don't want to deal with it. Did we saw the same thing earlier? Is it again same thing? What can we do about this? Is it the same image? Did you saw this image earlier? This is the same image, right? In this case, it is pod. So it's all blue basically within the cluster, but pods, multiple pods, stable IP. Now you are saying that we are within the we are in a section that is like shared. Okay, so nodes are there, node IPs are there, multiple node IPs, and I still need a single IP so that I can communicate with it. I don't want to deal with the node IPs. Okay, and your client can be public or or AWS, depending on in this case. Okay, so that's exactly what your next type of service does, the load balancer service. Okay, so load balancer service actually kind of allows you to do this. it gives you a stable, so it creates a load balancer essentially. As long as your AWS your cloud provider actually provides you the ability to do that. So Kubernetes can allow you to create a load balancer service. So it allows you to create a load balancer service which will give you a standard IP or a DNS name. Okay, and then you can use that to communicate with the application. Okay, so now let's try to see what a node IP cluster IP is. Okay, good. So now in this case, what we are saying is it's of type. The only thing we changed is actually it is of type load balancer. That's the only thing we changed. Almost nothing is changed, but a lot of things will be actually happening as part of it. So it actually creates a load balancer in AWS. We can apply this and then see. Okay, what is the name of this load balancer underscore service? Okay, get services will actually give you a service. Now there is something called as external IP that is sitting there, which looks completely weird, but you still have cluster IP, you still have a, let me get rid of this. You still have a mapping of some kind, which is still 3001 to 80 and a load balancer. Now let's check what it actually doing here. Okay, so if I go to the load balancer now. Okay, so this is the load balancer is got created as part of the new service. So that's why I showed it as a shared thing. This service is actually created as part of a Kubernetes resource, but Kubernetes is now creating a AWS resource, a cloud resource. So that's why if you see the color is like shared thing. Okay, so now what it is doing, it created a load balancer. So now if you go to listener, okay, listeners is where the similar thing what we said here. We are saying that our input port is 80. Okay, so same thing on the load balancer side is the listener. In case we are saying that listener, it is listening on port 80 and it is sending traffic on the instance port 3001. Okay, but which instances? Okay, so if you check the instances, these are the two instances that are there. So basically all our worker instances are here. You can even open it up and you can check that. Okay, you can see the names here itself. Okay, so these are the names of the instances. Okay, so it is essentially what it is saying is send me the traffic on this DNS name or IP address if you want to send it to IP address, but DNS is obviously better. So if you send it to this DNS on port 80, I will send this traffic to 3001 port on one of these instances. So almost similar to what you did for a service, it's doing that from within the AWS now. Okay. One more thing here is this guy has it is actually internet facing. Okay, because the way we have defined it is like public now. Okay, so it is essentially internet facing. That means now I don't need to go to Bastion or within the cluster or anything like that. I should be able to directly hit my customer service from my local machine over the internet. Okay, you can create a load balancer that is internal, then it is within the cluster, within the AWS. But in this case, we just go with the default. So now if I do curl -s, hopefully I copied this. Using the port 80 to listen, so I don't need to specify any port. Okay, I can just say customers/1. Okay, and to make it look good, okay, just formatted the JSON. But now I am able to hit to my service from my local. So now it is actually like you came out even outside of the AWS infrastructure. So great, we did achieve something, but that 3001 is like hard-coded thing, and it's across all the nodes. So if that port is not available, or if it's a shared cluster, this team is using, that team is using the same cluster, they might end up with the with a service definition that exactly use the same port. I don't want that. Okay, and earlier that was useful because we were using that port in our URLs, but now that thing is completely hidden. So I don't need to know about 3001. If you see the way we access this, there is no 3001 here. We just said send it to port 80, right? HTTP request goes to port 80. So I don't really want that to be a problem. That means what I can actually do is I can actually get rid of this and let it map it to a dynamic port. So that means if you go to the dynamic port, okay, so I got rid of the port association. Okay, so what we can do is now just apply this to the cluster. So it is even better now, get services. So now you can see that it is not a 3001 anymore. It is mapped to some random port. It ensures that the port is available across all the nodes. More the nodes, more problem is there in terms of figuring out the ports. Okay, so this is essentially is required. So now if I again from a client point of view, then nothing changed because we are not even using that 3001, or so it changed. I don't care. Okay, I should still be able to access the service. Okay, I am able to access the service. You should be able to see this change in your listener configuration. Oh, it is not there. Okay, so you can see that in the listener configuration. So all those things are changed in your cluster. Okay, so that is also good, which is a good thing. Now only thing that remains for this service at least is to add a DNS, which we are not going to do, but you can map a DNS, point it to your load balancer, and you are done. Basically, you got the service exposed over the internet. Okay, so this is what you got in a load balancer. You are getting two things changed a bit. You got the dynamic port mapping, which we use. You can hard code it if you want to, but we don't really need to. So there's basically dynamic node port, and you are getting a load balancer, which is in our case is internet facing. You can go with a internal load balancer as well, which allows you to access the this application from outside. All great, but I don't have one service. Okay, I have multiple services. Okay, we didn't even talk about product service. चैट में तो कुछ भी नहीं है. Sorry, how kubectl able to create a AWS resource like load balancer? It is not kubectl, it is creating it. So the question is how kubectl is able to create a AWS load balancer. So kubectl is not creating AWS load balancer. It is the, so we just created a service of type load balancer, and our setup is essentially aware in terms of that it is dealing with the, it is running on top of AWS. So any cloud that supports Kubernetes type load balancer service will create a corresponding load balancer on those cloud services. Okay, so that's where it is happening. So it is Kubernetes that is doing it, not the kubectl. Kubectl just created a service of type load balancer. That's it. Okay, so that is great. But coming back to the same thing, we didn't even talk about other service. So we don't have just one service. Okay, we have multiple services. I want to expose them in a uniform way. So let's first install the product service. So if I then do kubectl apply, so instead of this time I can go with product deployment. I can show that it's almost same to what you have for the customer service. Okay, the same thing, almost same thing. 3 replicas, pod template, pod is named as products. The image is different, but essentially the endpoint is different, but it's like very simple service. Container port is same because the application is running on the same port. Okay, so everything same, almost same as the deployment for the customer service. The same is for the product service. So if once we have created this, we should be able to see the pods. So now you have 3 pods for the customers, 3 pods for the product service. Okay, great. Okay. So we want something like this. Okay, what we want is some missing component. And again, we are back inside the cluster. Everything is again blue. We want something like this in which we send a request to some component. It figures out that if it is a customer request, it sends it to the customer. And if it is a product request, sends to the product. But from client point of view, it looks like as if I'm talking with one application. 2 endpoints, but one application. I don't need to know that whether customer is implemented as a monolith, as a microservice, different pods, same pods, all those things. Okay. So this is what we want to do. And this is what is called as the ingress controller. Okay. So ingress controller is a component that will allow us to do that. So it does a path-based routing for the pods. So in general, we can quickly talk about the Kubernetes controller. What is a controller? So you have a resource and there is a corresponding controller which is managing that resource. Okay. So that means in terms of examples, you have deployment resource, will be a deployment controller, corresponding controller. You have a replica set. We haven't talked about replica set, but replica set is one of the resource which will have corresponding replica set controller. Okay. You have a service resource, there will be a service controller. So any type that you create, there will be a controller. That means by this analogy, we are talking about ingress controller. That means there is something called as an ingress resource. Okay. So there is an ingress resource. Okay. Now generally ingress resource is like a plugin to Kubernetes cluster. So most of the previous examples, all the top examples are inbuilt in the Kubernetes. They are still independent component. You can write another controllers of the inbuilt things. So I can write my own service controller if I want to. Ingress controller is something that you generally install or deploy. Okay. So that means I already have done that. So I can show you that. So get pods. So if I say ingress nginx, get rid of all this. Okay, so I already deployed a pod for the ingress controller. So the controller installation I'm not going to cover. It is there in that page if you want to follow that, not this one. So everything that I've done till now is actually here, including prerequisite, including creation of the cluster, everything. Okay, and it's a public repo. You can go and check that. I will share the link on the meetup page. Okay, but the installation of that ingress resource is already done. Okay, install the ingress controller. What we can do is we can actually create. So controller is there. That means we need to create ingress resources. So we can create ingress resources for customer and the product service. Okay, let's do that. So first, let's see the services. So we have 2 types of services. Actually, we didn't create a service for the product service. Okay, so let's create a product service. Okay, so I can create a product service. Again, nothing much there. If you go and check the product service, all it is doing is of type cluster IP. So we are back to cluster IP, and is basically saying that accept traffic on port 80, send it to port 8080. That's all it is doing. Okay. So we have two services, customers and the product service. Customer service is load balancer. We don't want that. Okay, we don't need to have a load balancer for customer. We want to have it behind the ingress controller. So I'm going to actually revert back to the original customer cluster type well known. In this case, probably I will have to do a force because we have defined the node port. So I'm going to get rid of that. It gives you an error. When I was trying, it gives you an error. So in this case, even if it ends up with an error, it actually deletes and recreates the resource. So now let's go and check. So simple, coming back to the cluster IPs, okay, for customers and the products endpoint. Now let's talk about the ingress resources. So for the customer ingress, all we are saying is there is some host that I have defined. This is the domain name. You can give anything here. Right now, whatever I have given is going to matter later on, but at the current point, you can give anything here as long as you send the request with this domain. Okay, so what we are saying here, we are saying that this is of type ingress. Okay, we are creating a ingress rule. Okay, so we are essentially creating a rule. In this rule, we are saying that any request that comes with this domain or this host, and it has a path called customers as part of it, send it to the service called customer on this port. Okay, so we already have a service of customer which is running on, which is listening on this port. Okay, so what we are saying is if we send a request to the ingress controller pod with this host and with this URL, we should be able to reach to the to our pod. Okay, so let's actually do that. If you see the ingress for the customer and the ingress for the product is all same. Okay, just the instead of customer, it is saying products. So now what I will do is I will just create both of them. Okay, so if I say give me the ingress things, is actually showing me both the ingress that are created. It's not going to work just yet. So something is missing. Okay, it will take some time to actually populate that. Hopefully it will done. Okay, I have given a class. Okay, we are going to talk about this later, but now it is at least kind of ready. Okay, so we have two ingress controllers. One is called as customers, one is called as products. This is of type ingress. Okay, now what we are going to do is we can actually, so what we said is if we send it to, this is what we said, right? If I send my traffic to the ingress pod, switch to yeah, but it has picked up the, so it is going to work. I don't know why it is showing class as thing, but it will work because it picked up the changes. So I can try to see why it is showing that. Let's try to see that. I have given the class. You can see the class is given.
It is 90 onwards. It has to be specification in this last name.
I'm using 118. Okay, I'm using 118. Of course, things will change. So if you are using another version or lower version, you have to manage that. But Till now I have used everything lower than 118, so it should work if you're below 118. Okay, so let's try to actually send again from in okay, 1 minute. So we are now sending traffic to not our pods or even the service. We are sending traffic to the ingress pod. Okay, so for that we need the ingress pod and the IP address of that pod. So if I say this is the IP address of the pod. So we are still within the cluster. Okay, so now if I send a traffic to this pod, to this IP address, which port it is running on? It is port 80, so I don't need to do anything. Okay, I already have a rule that says that if it is /customer, send it there. But this is not going to work because I'm not using that host. Okay, so for that, what I need to do is I can do two things. I can actually add a host entry and say that this is the domain and this is the IP address which goes to the pod. Or curl actually gives you one more thing, which is to do a resolve. So you can say that map this to this particular thing, this IP, map this host to this IP. I can show you. Okay, so you can essentially do this. So in which what you are saying is, let me zoom this up. In which what you are saying is, this is my domain. Okay, I'm going to use that, but resolve this domain to this particular controller pod IP, which is the IP address of the controller pod. So I can say that and then send a request of this thing, which will send it to that. So request will actually show that it is for that particular host, but it will send to the right place. Okay, so that means I should be able to actually use this thing. That is clear, right? All I am doing is using the host IP, the host domain, but sending the traffic to the controller pod. Okay, so this is the IP address. Now if I just run this thing, I don't really need that port 80 most likely. Okay, so it is going to work. Okay, so now what we did is we sent it to the ingress controller. We had a rule to send the traffic to if it is /customer, send it to customer. So let's try this for the products as well. Okay, so this should also work because we have already created a product rule as well, or product ingress record as well. So this is also working. So same, so you can see that I am using the same domain, but just the path is changed. So now it is like a uniform service for me. Okay, it's like the client doesn't need to know that these are two different services and then send it two different things. So great, but we are still within the cluster. Okay, how do we actually access the ingress controller? We already solved that issue, which is basically, we already talked about this. Okay, which is basically, if we create a service on top of the ingress controller of type load balancer, then I should be able to use that load balancer to talk to the ingress controller, which in turn will talk to the pods. Okay, so that means if I already as part of the installation, the service already exists. I can show you that. Okay, so this load balancer type service already exists for the ingress controller. Okay, this is the load balancer address. It is sending it to this thing. We can check. So this is ingress controller service. We can check that it is actually sending it to the ingress controller pod. Okay, that means I should be able to use this load balancer. Now load balancer is public, so I should be able to just use it from my local. Okay, and just send the request to this load balancer. Okay, so this works. I should be also able to do the same thing for the products. Just change the path and reach to the product. So I don't need two load balancers for two services. I uniformed all of this into one behind the ingress controller. Okay, so both of them are working fine. Now, just one point, that the reason I named it like this is because your load balancer DNS is essentially like this. So this time we didn't do resolve or anything. We directly use that. The reason I use this hostname is because your load balancer essentially uses this, and this part is dynamic, so you can just use a wildcard for that. Okay, so that's how it is working end to end. Yeah, that's the main thing. So now you essentially use all the components that we talked about to communicate with a service or sets of application, not one service, multiple applications uniformly with a single URL from outside of the cluster at the public level till the pod. Okay, so we can quickly go through that just once. So what it is doing is, when I send it to that particular load balancer, this is the load balancer which sends. So now it is actually running HTTPS and HTTP, both of them, but we are just sending HTTP traffic. So in this case, it is sending it to this pod, to this particular node port, and that's where the service mapping is. You can see that the same service mapping is actually used. So not this one, the 360 is what is being used. Okay, which in turn sends it to the pod of the ingress controller, which in turn sends it to the service of the corresponding pod, corresponding application, and the service will send it to the pod. So that's what is happening end to end. So control, the load balance is there, ingress is there, ingress sends it to the service, service in turn sends it to the pods. That's the end-to-end flow. That's what the main thing that I wanted to cover as part of this talk. So end-to-end, we basically covered. Any questions? I might have rushed a bit, but you can actually go and follow all the steps that are there. Actually, much more than what I covered. It also talks about how to set up your cluster the way I have done, and almost everything. Are there any questions? Huh. Generally, it is deployed in its own namespace. So that's to just keep it separate than the application namespace. So not really part of your application. Yeah, so question was that why ingress was deployed as part of a different namespace. So generally you do that because you don't want to keep with this in the same namespace where your applications are running. That's generally the reason. Yeah, I think we can stop here. There was some bonus that I might have covered, but what I will do is there is a section here in this page somewhere around the DNS, which I didn't add, to add later. I can add that there, which you can follow and essentially go through that, how DNS is working within the Kubernetes cluster. So there is a question how to enable secure connections between pods using ingress. You can do that. Generally, what people does it, they ends the HTTPS communication at the load balancer. So you already saw that load balancer has a mapping, and ingress already gives you an ability to talk on 443. So this is where your HTTP traffic is being sent. So if you add so you can add a certificate here of your of your domain. That way you can secure your traffic essentially. And then you can also say that any traffic that comes on port 80, I don't accept that, and I redirect it to HTTPS port. So essentially you ask, come back with HTTPS, and your browsers automatically shift to HTTPS. They will send that traffic, and then you will be able to access that. Any other questions, or else we can stop here? Was this useful?
Yes.
Okay.
So the host rule from the ingress that is enforced by the pod, not by the security group or anything.
No, that is within the cluster, so nothing to do with security groups. If it is able to reach to the pod, ingress will, so ingress record is acting as a configuration for ingress controller. Ingress controller knows that these are the rules I need to basically follow, and any traffic that comes there, it looks at which rule actually matches. You can also define default rules that if nothing matches goes there, which I haven't done. So if it matches, then it essentially picks up that it knows which service I need to send to. That's what it is doing.
You define star.ap1, that rule is enforced again by the controller, not by.
That is looked up by the controller. Okay.
Because security group also has that which traffic from only certain places is allowed.
Security group is about reachability. This guy is not doing it about reachability.
You wrote resolve, right? That's why you
Aha.
did that. Because the
It's not doing a resolve. It is just matching that. It is doing that to match a rule.
yeah, I'm saying you wrote the resolve for the curl because the IP comes from
Resolve for the curl was for the client, nothing to do with the. So it is as good as localhost. Localhost goes to 127.0.0.1. It is done locally. Are you getting my point?
calling it from the engine explorer.
I am calling it from Nginx pod. That is not the controller, separate Nginx. So I am calling that from there. I'm saying that this is my URL. So URL is sent, but sent where? It need to be, there is no domain called test dot something something, right? So it is sent where, that's what the resolve is actually giving. So use this domain as part of the URL. So URL remains with this thing, but it actually resolves to that the IP address. Is that now clear? So it is exactly like doing an entry in etc host. Okay.
You had two manifests for ingress, right? Two different manifest size for ingress.
For customers and the products, yes. You can add multiple paths, yes.
To work similarly.
It should work the same way, yes. But generally you do separate because you want to keep them separate. Generally you put a Helm chart and all that thing, and then it's all separate. So
And for the online people, we can have the chat offline.
yeah, so if there is no more question, actually there is one question. Does ingress controller take care of creating load balancer as well? So no, ingress control is not creating a load balancer. So if you see the example here, ingress controller is only looking at the rules that we have defined. If anything that comes with /customers is sent to customer service, anything that comes with /product is sent to product service. The load balancer in front of ingress controller is created because we created a service of type load balancer. Okay. Does that answer your question?
Yep, sure. Thanks, Prashant.
So I can't hear anyone. You can just say it in the chat, or maybe you guys can tell me.
Okay.
So load balancer is created because load balancer service is created for the ingress pods. Yeah. So I'm. If there are no more questions, maybe we can close the online call. Yeah, I don't think there are. Okay, thank you for joining, everyone. Thanks. Bye. How do I stop share?